Now, let's take a closer look at the intelligence of our air-to-water system. At the heart of our air-to-water technology is our R2 system. Our R2 system is designed for simultaneous heating and cooling with 2 refrigerant pipes, unlike the 3 pipes used in conventional market products. With the 2-pipe system, the BC controller houses a liquid and gas separator, allowing the outdoor unit to deliver a mixture of hot gas for heating and liquid for cooling, both through the same pipe. An LEV, or linear expansion valve, delivers appropriately phased inputs to each indoor unit, depending on the individual heating or cooling requirements. In heating mode, gas refrigerant is delivered to the indoor units. If heating and cooling are required in the same system, the LEV switches the refrigerant flow. The gas refrigerant delivered to the indoor units in heating mode circulates back as condensed liquid refrigerant and is then delivered to the indoor units in cooling mode. In this way, the more frequently cooling and heating operations are simultaneously carried out, the higher the energy savings from reusing waste heat. This reuse of waste heat also applies to the air-to-water system, which supplies hot water with its heating cycle and utilizes the waste energy for cooling. The air-to-water series consists of 2 types: a booster unit and a heat exchanger unit. The booster unit offers hot water to a maximum of 70 degrees Celsius. The heat exchanger unit offers up to 45 degrees Celsius in heating mode and down to 10 degrees Celsius in cooling mode. Both units are suitable for residences, office buildings, restaurants, or hotels, providing an optimal indoor environment while reducing running costs and environmental impact. The booster unit is equipped with a compressor and a 2-plate heat exchanger, in which the R134A refrigerant circulates. High-pressure R410A gas refrigerant is delivered from the BC controller. The R410A refrigerant heat exchanges with the low-pressure R134A liquid refrigerant circulating through the first heat exchanger and circulates back to the BC controller as high-pressure liquid refrigerant. To raise the temperature, low-pressure R134A gas refrigerant is compressed by the compressor to become high-pressure gas refrigerant. Compared to the R410A refrigerant, R134A refrigerant requires less pressure to raise the temperature. To supply hot water, high-pressure R134A gas refrigerant exchanges its heat with the water entering the booster unit. The hot water circulates to heat the water inside the tank, which will be used for showers, floor heating, or panel heaters. In the full system, the booster unit is connected to a BC controller with refrigerant pipes and to the water tank with water pipes. And to complete the system, it is also connected to outdoor and indoor units. The air-cooled and water-cooled series outdoor units are connectable depending on the system structure. The BC controller connecting the booster unit and indoor unit allows simultaneous cooling and heating operations. Depending on usage, a simple type of BC controller, called a Water System Connection Box, or WCB for short, can be connected. With a standard BC controller, the booster unit can supply hot water and cooling and heating operations to indoor units. For example, in an office, the air-to-water system can supply hot water in small kitchens, cool machine rooms, and heat office areas. When using a WCB, hot water supply is also available, but the operation of indoor units is restricted to either cooling or heating. In restaurants, hot water can be used in kitchens, and cooling or heating is available in the dining rooms. Next, let's take a closer look at the air-to-water heat exchanger unit. Heat exchanger units are not equipped with compressors. In an R2 system, high-pressure R410A gas refrigerant is delivered from the BC controller. Water entering the heat exchanger unit is heat exchanged with the high-pressure R410A gas refrigerant to supply hot water. Gas refrigerant carrying away heat returns to the BC controller as a high-pressure liquid refrigerant. Hot water up to 45 degrees Celsius can be provided with heat exchanger units. Moreover, they not only can supply hot water, they can also supply cold water down to 10 degrees Celsius. Cold water utilizes the cooling operation cycle. It delivers high-pressure liquid refrigerant through a BC controller. The refrigerant heat is exchanged, cooling the water entering the unit. Then, the refrigerant returns to the BC controller as high-pressure gas refrigerant. Hot water can be used for floor heating and panel heaters. And cold water can be used for cooling operations and fan coil units, machine cooling, food processing, flower shops, and for pet and plant preservation. With an R2 outdoor unit, the heat exchanger unit is connected to a BC controller with refrigerant pipes and to the water tank with water pipes. Both standard BC controllers and WCBs can be connected to the heat exchanger unit. The heat exchanger unit can also be used with the air-cooled Y series or water-cooled WY series outdoor units, but there will not be a heat recovery operation. By providing an optimum ambient environment and hot water up to 70 degrees Celsius, booster units are ideally suited for a wide range of applications, from office buildings, gyms, and health clubs to hotels and nursing homes. Heat exchanger units can supply cold water down to 5 degrees Celsius and hot water up to 45 degrees Celsius. Other than cooling or heating rooms, they can also handle applications such as machine cooling. Also, comparing the air-to-water series to conventional boiler systems, the air-to-water series offers an energy-conscious and environmentally responsible solution, which reduces CO2 emissions using waste energy. Mitsubishi Electric, always at the forefront of the very latest technology, developed the Air-to-Water series to provide yet another high-performance and competitive system on which our customers can rely.